So now let's go ahead. We're going to start section 4. So we're skipping from section 2 to section 4. So we're skipping quite ahead in our notes. So let's go all the way to page 16 in our note packet. So up until this point, we've been talking about standard form. So standard form is where we have, first of all, there's no parentheses. And we have A, B, and C. So this is what we've been talking about. Standard form, A, B, C, axis of symmetry. Then we've been finding the vertex, using the table to graph. So this is where we started out with. Now we're moving on to the second way, which is factor form. Okay, anytime you're absent though, just write absent. Just write absent in the box. You don't have to copy bell work. Just write absent, put it in the red tray, move on. It's not that big of a deal. Okay, so factor form. Factor form, the focus is on the x-intercepts. So this is what we're focusing on when it's factor form. The x-intercepts. Or the root or the solution, okay? Now, we kind of talked about this a little bit. I don't know if you remember. I think it was the second day of school where we had the x and we had to find two numbers that multiply to the top, added to the bottom. That's the first step in factoring, okay? So that's what we're going to focus on now. After we take our quiz, oh, I forgot to plug in my computer. After we take our quiz next Friday, we're going to focus on the third method, which is vertex form. All right, so let's go ahead and get to it. So factor form. So let's start off by solving quadratics that have already been factored. These are already factored. We're just setting the parentheses equal to 0 to find the solution. So if I start off with x plus 5, I set that equal to 0. And then I take the x plus 3 and I set that equal to 0. So these are the factors. But to find the solution, we have to solve it for x. So in order to solve the first one, I'm subtracting 5. So what is 0 minus 5? X equals negative 5. That would be my first x-intercept. I would have an x-intercept at negative 5. For my second one, I am subtracting the 3. And I would have x equals negative 3. That's my second x-intercept. All right, let's look down. We're going to skip this one. Let's go down to the one below it. This x, anytime it's a variable like a x, if it's a 2, that's not a solution. But if you can factor out an x, that is a solution. So this would represent a factor. Set that equal to 0. That is already solved. There's nothing we need to add or subtract. The answer would simply be 0. So x equals 0 would be a solution to this quadratic. It would be an x-intercept. Now let's take the x plus 4. You set that equal to 0. Go ahead and solve it for x. Remember, you have to do the inverse to solve it, the opposite. So x equals -4 would be my second solution. Again, these are all x-intercepts. That's all we're focusing on. Now, when we look over at this one, this has a fraction for a solution. That 2x plus 1, set that equal to 0. We have to do two things to solve that for x. So for this one, we would have a fraction, or you can also write it as a decimal. So one of our solutions would be either a fraction or a decimal. So for the first one, in order to solve it, I would subtract 1 from both sides. Zero minus 1 is -1. And then how do I get rid of the 2? What's the opposite of multiplying by 2? Dividing by 2. So my second solution, or not my second, my first solution would be -1/2. Now, I normally keep my answers as fractions, but I will also accept a decimal. So if you wanted to write it as -0.5, that would be fine also. And then now we're going to take the x minus 7. Set that equal to 0. Add 7. And you should get x equals +7. So again, all of these that we found, these all represent my x-intercepts. And that's what we're focusing on today. We're focusing on finding our x-intercepts, and sketching a graph. So the graph that we do today won't be as accurate as the graphs we've done before, because we're not finding 5 points. We're just finding 2. So these are all my x-intercepts. So let's go ahead and get started. Page 17. So when you are factoring, the first thing you always want to do is make sure that it equals 0. And when you have an equation that says y equals, you can replace the y with a 0. The second step is look for a greatest common factor. A is 1, B is -6, and C is -27. We don't have a number that will go into all three of those numbers other than 1, so we don't have a GCF. So now we're going to make our x. This is what we did on the second day of school. So we're going to make our own x. So make your x. On top of the x, we're going to put A times C. So in this example, A is 1, B is -27. 1 times -27 is -27. That goes on top. On the bottom, we put our B. And what is B? What number is B? -6. Put that on the bottom. All right, here is the trick. Don't say it out loud. Take out your multiplication charts if you need to. If you didn't get one, I have plenty over there. This is the trick to factoring, okay? You need to find two numbers that multiply to -27 but add to -26. And the only way we can get a negative on top is if one number is positive and one number is negative. So don't say it out loud. This is the hardest part. This is where we all need to practice. Think of your two numbers. They have to multiply to give you a -27 and add to a -6. They have to match both of those rules. Multiply to -27, add to a -6. One number is positive, one number is negative. Because the 6 is negative, that means the bigger number is negative. So just give me a thumbs up if you know my numbers. I'm not gonna call on anybody. I'm just trying to see where we are. All right, I'm gonna give you all about another 60 seconds to think about it. Or 30 seconds. So if you're using your charts, look for the number 27 on your chart. See what two numbers give you that 27. And I'm pretty sure it's only one option. There's only one pair of numbers that will give you 27. Does anybody want to volunteer those two numbers? Is it Malik?
Makai.
What is it? Makai. Makai. What's my numbers? +3 and -9. Okay, now this is important because we're going to do the harder factoring questions on Monday. Anytime you have A as a 1, if A is a 1, we can do a shortcut. So I want you to go directly down to the factors and make your 2 parentheses. Put an X in front of both. These are the factors. We can do a shortcut. And I want you to put those 2 numbers that Makai gave us in the parentheses. So in one, I want you to put a +3. In the other one, a -9. Those are the factors. But to find the roots, remember, see how there's 4 different terms that all mean the same thing. A root, a zero, an x-intercept, or a solution. In order to find this, just like we did in the last examples, we have to set the factors equal to 0. So let's take the x plus 3, set that equal to 0 and solve it, and take x minus 9, set that equal to 0 and solve it. So I'm subtracting the 3. So that gives us x equals -3. So x equals -3 would be my first solution. So I'm gonna write that here. Yes. Passes are over there. And then for my second one, I'm adding 9. So this is how we're going to do our sketch. So it's not an accurate graph. We're not doing 5 points like we did. All I want you to do is go to your x-axis, put a point at -3, and put a point at +9. And then draw a smile. It's a sketch. This is not accurate. That's what a sketch is. So that would be my solutions. That's my solutions, and that's my sketch, and that's it. Now, that is not the vertex. The vertex is not where I put it. If we wanted to find the vertex, we have to do all the steps. Find the axis of symmetry, then put that number back in. But that's not what we're doing right now. We're just making a sketch. Any questions? So 1.4 is all about finding the x-intercepts. All right, let's go ahead and look at the second one here. So remember, the first step is to set it equal to 0. Do you recognize that this is not equal to 0? This is equal to -3. So what I need to do is, what's the opposite of -3? So I'm going to add 3 to the like term, which is 7. That's the only term that I can add the 3 to. You can't add 3 to an x squared or to an x. So now I have x squared minus 7x plus 7 plus 3, which is 10. That equals 0. So I have A, B, and C. Let's make our x. On top of the x, we're putting A times C, which will be 1 times 10. On the bottom is B. Don't say it out loud, but I'm looking for two numbers that multiply to be a positive 10, but add to a negative 7. And the only way that can be true is if both numbers are negative. So go ahead and take a moment. You're looking for two numbers that multiply to a positive 10, but add to a negative 7. All right, anybody want to volunteer my two numbers? Dwayne. -2, -5. So again, only because this number is 1. That's the only reason why we don't have to make a box. We're going to go straight down here, make our 2 parentheses, put an X in front of both, and then put the two numbers that Dwayne gave us. -2, -5. That's the factors. Now solve it. Take x minus 2, set that equal to 0. X minus 5, set that equal to 0 to get your two solutions. So for my first one, I have to add 2. So that'll give me x equals 2. For my second one, I'm adding the 5. And that'll give me x equals 5. So on your graph, put a point at +2, a point at +5, draw a smile. Again, this is not the actual graph. This is what we call a sketch. A sketch is not accurate. Now, the graphs we did before were way more accurate. This is just a general sketch. Emily, are you okay? You need to go to the nurse. All right, any questions? All right, just a few more and then we will be done for today. Well, 3 more to be specific. So I'm gonna go ahead and help you set this one equal to 0, and then after that I want you to factor it and solve it. I'm gonna come around and see what we get, but let's go ahead and get started by setting it equal to 0. So the first thing I need to do is subtract 8x. You can only subtract 8x from 6x. So I'm gonna subtract 8x. I also need to get rid of the -4. I'm going to do that by adding 4 to the -7. So when you see that, do you see how both of these cancel and I have my 0? So let's see what we have here. Bring down your x squared. Take 6 minus 8. 6 minus 8 in your calculator. See what you get. What's 6 minus 8? What is it? Negative 2x. And then we have negative 7, because if there's a subtraction sign in front, that just means it's negative. So we have negative 7 plus 3, which is a negative 3. All right, so A, B, C. Make your x on top. You have A times C. On the bottom, you have negative 2. Yes.
Did we just combine like turn over?
Yes. We set it equal to 0. All right, so go ahead and factor it down. Come and see what we come up with. Factor it, find your two numbers, write your factors. Well, we didn't combine like terms because they weren't on the same side. I had to do the opposite to bring it over. Yeah. So, two numbers, all right, yes. Yeah, I'm gonna come up, okay, no comma though, no comma. It should just be, no commas in none of these. The factors don't have commas. No commas in the factors. Yes. Y'all asking for a lot. I'm gonna have to come up with a new pass policy in this class, cause y'all driving me nuts, like for real. I'm gonna talk to the other teachers to see what they got going on, but go ahead, you can write it, but next week is a new story. Yeah. It's too much, in and out, it's a distraction. Two numbers that multiply to give you negative 3, but add to a negative 2. The only way we can get a negative on the top is if both are negative. They both numbers have, no, I'm sorry. The only way we can get a negative on top is if we have a negative number and a positive number. So start thinking about numbers that multiply to give you 3. There's really only one option that multiplies to be 3, right? What's the only thing that multiplies to 3? 1 times 3. It's just 1 times 3. And you just have to figure out which one is negative, which one is positive. This is negative. If you add these, you get a negative 2. So I'm seeing a lot of people put 3 and 1 as the numbers, but the signs are wrong. So make sure when you add them, both of these have to be true. So if you pick two numbers that multiply to negative 3, but don't add to negative 2, that's not right. Both have to be true. So back up, make sure so we are actually getting the right numbers. page 17 at the bottom. So what were the numbers that we came up with? They multiplied to give you -3, add to a -2. -3 and +1. That's important. A lot of people had the signs mixed up. A lot of people put a +3 and a -1. That's not right. For your factors. The other thing that I'm seeing a lot is commas in the factors. There shouldn't be any commas. No commas. No commas. No, 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 no. That's an ordered pair. We're not, these are factors. That's different. So what you should have is a X. And then whatever number, you see how there's a -3? I'm just going to put a -3. No commas. And then I have a +1. I'm going to put a +1, just like that. So then we're going to take our x minus 3, set that equal to 0. Add 3, you get 3. And then we have x plus 1. Set that equal to 0. Subtract 1, you get -1. So x equals 3. X equals -1. Go ahead and make your sketch. One point is at -1. Another one is at +3. Draw your smile. This is not accurate. I want to keep reiterating that. We don't know where the vertex is. I don't know where it does a U-turn unless I do axis of symmetry and plug that number back in. All right, so now let's move on to looking at a graph and writing the equation. I realize that your graphs are not that clear. So let's go ahead and rewrite these x-intercepts. So this is -2, 0. This one is +2, 0. So this is an x-intercept. If I'm going from x-intercept, Will May, I need your head up. X-intercept to, I'm going to let y'all sleep. I think it's rude, but this generation is disrespectful, so go ahead. All right, x-intercept to a factor, you have to flip the sign. You have to flip the sign. That's the only way to do that. Okay? You have to flip the sign. So whatever number I have for my x-intercept, when I write the factor, I have to flip it. So I'm going to go ahead and make my two parentheses. Put your x in front of both. Okay, so now I'm looking here. I want you to look at the -2. You see how there's a -2? What's the opposite of -2? If I flip the sign for -2, what does it become? +2. So I want you to put a +2 in the first factor because it's the opposite. And then I have a +2. So I'm going to put the opposite of a +2, which is a -2. And the last thing is, if it's a smile, you have to put a +1 in the front. So this is a smile, so I am going to put a +1 in the front. That would be my equation. From a graph to the factors, that's what it would look like. Okay, let's look at this one. Again, I know your graph is blurry. So this is -1, 0. And this is actually a +5, 0. You can go ahead and put that there. So am I going to start this equation with a +1 or a -1? Plus, because it's a smile. So the first thing I'm going to put on the line is a +1. Go ahead and make your two parentheses. Put an X in front of them both. All right, this is a -1. The opposite of -1 is what? +1. So put a +1 in the first parentheses. second parentheses, instead of a plus 5, I'm going to put a minus 5, and that would be my answer. All right, last one, last graph. So this is 0, 0. This is 2, 0. I don't care about the vertex. I only care about the x-intercept. See how this one gave me the vertex? I don't care about it. That's not what I'm doing right now. I'm only focusing on the x-intercept. So am I going to start this one with a plus 1 or a minus 1? Minus 1 because it's a frown. Let's make our 2 parentheses. Now my first solution is 0. 0 doesn't have a sign. There is no sign. So all I'm going to put in my first parentheses is an x by itself. You could put x plus 0, x minus 0, but normally we don't talk about adding or subtracting 0. We just put the x. And then we have a plus 2. And what's the opposite of plus 2? Negative 2. And that would be my factor. Okay, we only have one more question, and we will be finished for this week. Monday and Tuesday, we're going to finish factoring. Wednesday and Thursday, we're going to review. Friday, we have our first quiz. It's a quiz, not a test. It's 50 points. All right. So last one, we're going to set this equal to 0. I'm just going to write this right here. So I have to subtract 4x from both sides. However, these are not like terms. So they don't combine. So what I have is x squared minus 4x equals 0. So x squared means I have x times x minus 4 times x. What do I have written in both blue and red? What do they both have in common that I could take out? X. That's my GCF. So I'm taking that out. So that is a factor. One of my factors is just x. In parentheses, I'm going to write what I have left. X minus 4. So this is what it factors down to. That's my factors. All right, let's set these equal to 0. So I'm going to take my x, set that equal to 0. That's already solved. There's nothing we can do with that. So that means 0 is my first answer. And then I'm taking the x minus 4. I'm setting that equal to 0. Go ahead and solve that to get your second answer. So what would be my second answer? Positive 4. So let's go ahead and do our sketch. On the x-axis, put a point at 0, which is where they come together. A point at positive 4 and draw a smile. And that is it. We are going to